At 11:30 in the morning on November 7th, 1943, Hauptmann Hans Werner Lersch walked around a captured Republic P-47 Thunderbolt at Rechlin Airfield in Germany, studying an American fighter that would fundamentally change German understanding of how America fought wars. The aircraft was massive. Fully loaded weight exceeded 7,600 kilograms, almost twice the weight of a Messerschmitt Bf-109. The cowling alone looked bigger than some fighters' entire fuselages. To German eyes trained on lean, efficient designs, the Thunderbolt seemed absurd, wasteful, almost comically oversized. The aircraft had been captured 3 days earlier when Second Lieutenant William Edward Roach, 22 years old from Pennsylvania, made a navigation error that would give Germany its first complete, flyable Thunderbolt. November 7th, 1943, Roach was flying his third combat mission with the 355th Fighter Group, 358th Fighter Squadron, based at Steeple Morden, England. The mission that day was completely separate from the large 8th Air Force bomber operations targeting Wesel and Duren, while 112 B-17 Flying Fortresses from the 1st and 3rd Bombardment Divisions attacked those targets with escort from 283 P-47s from the 4th, 56th, 78th, 352nd, and 353rd Fighter Groups. Roach's unit flew a different mission entirely. The 355th Fighter Group was assigned to escort 9th Air Force B-26 Marauder medium bombers attacking German airfields at Montdidier and Moulins in occupied France. These were tactical strikes against Luftwaffe bases, separate from the strategic bombing campaign. The 358th Squadron launched 12 P-47s for this mission. Roach was flying as spare aircraft, the backup position. If any primary aircraft developed mechanical problems, he'd replace them in formation. If all aircraft functioned properly, he'd return early to base. 10 minutes after takeoff, Lieutenant John Lanfear's P-47 developed engine trouble. Oil pressure fluctuated. Engine temperature climbed above normal limits. Lanfear couldn't continue. He radioed that he was aborting and returning to Steeple Morden. Roach moved up from spare position into Yellow Flight's number 4 slot. He was now committed to the full mission. The weather over northern France that morning was brutal. Thick cloud layers extended from near ground level up to 20,000 feet. Visibility inside the clouds was near zero. Outside temperature dropped to minus 15 degrees Celsius at altitude. Ice formed on wings and canopies. Navigation relied entirely on instruments, dead reckoning, and radio compass bearings. There were no visual reference points, just grey clouds in every direction. The B-26 bombers attempted to locate their targets, but conditions were impossible. The mission commander decided to abort. The bombers jettisoned their loads over water and turned for home. The escorting P-47s turned with them. That's when the real problems began. The return flight encountered severe headwinds that hadn't been in the weather forecast. Wind speeds exceeded 100 miles per hour at altitude, blowing directly from England toward France. The P-47s were fighting massive headwinds while trying to reach home. Fuel consumption rates skyrocketed. Aircraft that should have had comfortable fuel margins suddenly faced critical shortages. Yellow Flight descended through the clouds for the return trip to England. Roach lost visual contact with his formation in the thick overcast. He flew by instruments, maintaining what he believed was the correct heading for England. When he broke out of the clouds at 8,000 feet, he expected to see the English Channel. Instead, he saw French farmland. The ditto winds had blown him far off course. His fuel gauge showed maybe 40 minutes of flying time remaining, not enough to find England. He spotted an airfield below with grass runways and buildings. It looked like a British advanced landing ground. Roach decided to land, refuel, and continue home. He circled once, lowered landing gear and flaps, and made a smooth landing. A jeep met him and led him to a parking area. Roach shut down the engine and opened the canopy. That's when he saw Wehrmacht soldiers carrying rifles approaching his aircraft. He'd landed at Carpiquet Airfield near Caen, France, a Luftwaffe base. He'd flown straight into enemy territory. The German soldiers pulled Roach from the cockpit. Within hours, he was on a truck to a prisoner of war camp, Within a day, he was at Stalag Luft 1 near Bath, Germany, where he'd remain until Soviet forces liberated the camp in May 1945. 3 other pilots from the 358th Fighter Squadron were lost that same day, all from the same fuel exhaustion problem caused by the unexpected severe headwinds. The squadron lost 4 aircraft total from one mission, an unusually high loss rate for a mission with no enemy contact. Captain Walter Kossak was Yellow Flight leader, the most experienced pilot in the formation. He was an instructor pilot with significant flying time. When his fuel ran critically low, Kossak attempted to reach the French coast and belly land on a beach. He made it to within miles of the coastline before his engine quit. He executed a perfect belly landing in a field near the coast. German forces captured him within an hour. He was sent to the same prison camp as Roach, Stalag Luft 1, where both men would spend the next 18 months. Flight officer Chester Watson wasn't as fortunate. Watson was flying in a different element of the formation. His fuel situation became critical while still over water. He had 2 choices: try to make landfall and risk crashing on the French coast where Germans would capture him, or bail out over the Channel and hope for rescue by British Air Sea Rescue Services. Watson chose to bail out. He left his aircraft over the English Channel approximately 10 miles from the English coast. The water temperature in November was 9 degrees Celsius. Survival time in water that cold was less than 1 hour, even with proper equipment. Watson was never found. He was declared killed in action. His body was never recovered. Lieutenant Jack Wirtz was the only Yellow Flight pilot besides Roach who made it back to England, but barely. Wirtz flew on fumes for the final 30 miles. His fuel gauges showed empty. The engine was running on whatever fuel remained in the lines. He crossed the English coast and saw Hastings ahead. There was an airfield there. He called the tower and declared an emergency. He had no time for a normal traffic pattern. He came straight in, gear down, praying the engine wouldn't quit before touchdown. The Pratt & Whitney R2800 coughed and sputtered on final approach. Wirtz was at 200 feet when the engine died completely. The propeller windmilled uselessly. The P-47 became a 7,000-kilogram glider. Wirtz held the nose up, maintained airspeed, and stretched the glide. He cleared the airfield boundary fence by 3 meters. The Thunderbolt touched down hard on the grass runway, bounced once, and rolled out safely. Ground crews found the fuel tanks completely empty. Not a drop remained. Wirtz had flown every mile he possibly could from that fuel load. The squadron's mission report that evening listed 4 aircraft lost, 2 pilots captured, 1 killed, 1 aircraft damaged in emergency landing. All losses attributed to fuel exhaustion from unexpected headwinds. No enemy contact, no combat damage. Just weather and navigation errors that turned a routine mission into a disaster. For the Luftwaffe, Roach's capture was extraordinary luck. They'd been fighting P-47s for months, but had never captured one intact and flyable. German pilots had shot down dozens of Thunderbolts, but crashed aircraft were usually too damaged for useful evaluation. Burned wreckage revealed little about how the aircraft was actually built. This capture was different. The aircraft was perfect, engine undamaged, structure intact, systems complete. Even the fuel tanks and ammunition were still in place, though empty. The captured Thunderbolt, serial number 42-22490, nicknamed Beetle, with squadron code YFU, stayed at Carpiquet for 2 days. Luftwaffe ground crews photographed every detail and documented all markings. They painted over the American stars with German crosses and painted the nose cowling yellow, the standard Luftwaffe marking for captured aircraft warning anti-aircraft gunners not to shoot. The Thunderbolt was then flown to Rechlin, Germany's primary aircraft test and evaluation center. Rechlin, officially Airprobungsstelle Rechlin, had been testing German prototypes and captured Allied aircraft since 1926. By 1943, approximately 4,000 personnel worked at the facility evaluating every aspect of aircraft performance, structure, and systems. The P-47 evaluation began immediately. German engineers had been fighting Thunderbolts over France and Germany for months. The aircraft looked ungainly, flew like trucks at low altitude, and turned like cargo planes. But they kept coming back with battle damage that should have been fatal. Pilots who should have been killed by flak or cannon fire returned to base with holes in wings, fuselages riddled with bullets, engines damaged and still flying. And there were always more of them. Every week, American formations grew larger. Every week, more Thunderbolts appeared. German engineers needed to understand why American aircraft were so difficult to destroy. The answer was in the details of this captured Thunderbolt. Hauptmann Hans-Werner Lärcher was Rechlin's senior test pilot. He'd flown over 100 different aircraft types by 1943, including multiple captured Allied fighters. He was methodical, experienced, and highly skilled. On his first walk around the Thunderbolt, he noticed the size. German fighters were compact. The Bf-109's cockpit was so tight that tall pilots couldn't fly it. The Thunderbolt's cockpit was enormous. A pilot could stretch, adjust position, even stand halfway up if needed. Lärcher started the Pratt & Whitney R2, 800 engine, 18 cylinders in 2 rows, air-cooled, displacing 46 litres. The radial engine fired with a deep rumble that shook the entire aircraft. German fighters used inline liquid-cooled engines that ran smooth and refined. This radial sounded crude, almost agricultural, but it ran perfectly. Temperature stable, oil pressure correct, no vibration. Lärcher taxied to the top runway. The Thunderbolt felt heavy, sluggish. He advanced the throttle and began his takeoff run. The aircraft needed nearly 500 meters of runway. German fighters needed half that distance. Once airborne, Lärcher climbed to test altitude. Below 15,000 feet, the Thunderbolt felt exactly as German pilots had reported. Heavy. Poor turn rate. Mediocre acceleration. Every maneuver required planning. There was no instinctive flying, just brute force physics. But above 20,000 feet, something changed. The turbocharger engaged fully. Power increased dramatically. The engine that seemed crude at low altitude suddenly became efficient and strong. Lärcher pushed the throttle forward and felt genuine acceleration. He rolled into a dive. The Thunderbolt dove faster than any fighter he'd flown. The heavy airframe that seemed like a liability became an advantage, building speed quickly and holding it through the dive. He pulled out and climbed vertically. The Thunderbolt maintained energy through the climb. Above 25,000 feet, roll rate was excellent. Controls that felt mushy low down became crisp and responsive. Lärcher flew for 40 minutes, testing every maneuver. When he landed, his initial assessment was clear. The Thunderbolt was built differently. Everything about it contradicted German engineering principles. But it worked, and understanding why it worked would reveal something important about American strategy. Over the next several days, German engineers at Rechlin conducted the most thorough evaluation of an American fighter they'd ever performed. Every system was examined, every component was measured, every design decision was analyzed. The evaluation team included structural engineers, propulsion specialists, armament experts, and aerodynamics analysts. They worked methodically through the aircraft from nose to tail. The first revelation came from examining the structure. German aircraft were masterpieces of weight optimization. Every component was engineered to minimum weight while maintaining adequate strength. Messerschmitt and Fokker-Wulf engineers calculated stress loads with extreme precision. They used the thinnest aluminum that could handle expected forces. They spaced structural members as widely as possible while maintaining rigidity. They eliminated every unnecessary gram. The result was light, efficient, fast, and agile aircraft. The Thunderbolt represented the opposite philosophy. The fuselage structure used aluminum sheet metal nearly 2 millimeters thick, where German practice used 1 millimeter or less. Longerons, the main structural members running the length of the fuselage, were built from channel sections 5 millimeters thick. German longerons typically measured 3 millimeters. The formers, circular frames giving the fuselage its shape, were spaced 30 centimeters apart. German practice spaced them 50 to 60 centimeters apart to save weight. German engineers calculated that the Thunderbolt's fuselage was overbuilt by a factor of nearly 2 to 1. The structure could withstand load factors of 15G before failure. Fighter requirements specified 8G capability. The fuselage weighed approximately 1,200 kilograms more than necessary by German engineering standards. The wing structure showed the same pattern. The main wing spars looked like they belonged on a medium bomber. Each spar was an extruded aluminum I-beam over 10 centimeters tall and 8 centimeters wide with 4 millimeter thick webs. German wing spars were typically half that size. The wing ribs were stamped from thick aluminum sheet and heavily reinforced. German ribs were made as thin and light as possible, just strong enough to hold shape and transfer loads. Engineers ran structural calculations on the wing. They determined the Thunderbolt's wings could handle ultimate loads exceeding 20 G before catastrophic failure. No fighter would ever pull 20 G. Human pilots would black out or die at 9 or 10 G. The wings were designed for loads that could never occur in reality. One German structural engineer wrote in his evaluation notes, "The Americans build bridges when they should build aircraft. This structure is absurdly overbuilt. We could reduce weight by 1,000 kilograms and still have adequate strength for any combat maneuver. This is wasteful engineering." But another engineer recognized the real purpose. He wrote, "The overbuilt structure is not about flight performance. It is about manufacturing and field operations. With this much excess strength, manufacturing tolerances can be much wider. Less skilled workers can build components. If rivets are not perfect, the structure compensates. If welds are slightly defective, the excessive strength means they still hold. Battle damage that would catastrophically fail our lightweight structures is survivable here. The Americans are not designing for maximum performance. They are designing for mass production by unskilled labor and battlefield survival." That insight explained much of what German pilots had reported from combat. Thunderbolts returning to base with battle damage that should have been fatal. Wings with dozens of holes still generating lift. Fuselages riddled with cannon fire still maintaining structural integrity. The overbuilt design meant damage had to be extraordinarily severe before causing catastrophic failure. The empty weight specification showed this clearly. The Thunderbolt weighed 4,490 kilograms empty. For comparison, a Messerschmitt Bf 109G weighed 2,700 kilograms empty. A Focke-Wulf 190A weighed 3,200 kilograms empty. The Thunderbolt was 65% heavier than a 109 and 40% heavier than a 190. That weight penalty directly impacted climb rate, turn rate, and acceleration, but it provided massive structural margins that kept pilots alive. The second discovery came from the engine. The Pratt & Whitney R2800 radial engine weighed over 1,000 kilograms by itself. German engineers preferred inline liquid-cooled engines because they were more aerodynamic and efficient. Radial engines were considered old technology. German engineers ran the captured engine on a test stand at full power for extended periods. They deliberately damaged it to test durability. They removed spark plugs from 3 cylinders. The engine kept running with reduced power. They punctured the oil cooler. Oil pressure dropped, but the engine continued operating. They shot bullets through 6 cylinders. The engine ran rough but didn't seize. A German inline engine with its liquid cooling system would fail immediately from coolant loss. Radiator damage meant engine failure within minutes. The Thunderbolt's radial engine could lose multiple cylinders, suffer oil system damage, take battle damage that would destroy any German fighter, and still bring the pilot home. It wasn't about performance, it was about survival. The third discovery was the armament philosophy. 850 caliber Browning M, 2 machine guns, 4 in each wing. Total ammunition capacity 3,400 rounds, 425 rounds per gun. That was nearly 20 seconds of continuous fire. German fighters typically carried enough ammunition for 5 seconds of firing time. American doctrine wasn't about precision, it was about volume. German pilots trained for years, learning deflection, shooting, and gun sight discipline. American pilots received months of training and learned combat tactics in the field. So Americans compensated with ammunition. Miss the first burst? Fire again. Keep shooting until something hits. 8 machine guns were far easier to manufacture than cannons. The ammunition was simpler, cheaper, produced in enormous quantities. The entire system was designed for mass production and minimal training requirements, not engineering excellence. Every system in the Thunderbolt prioritized industrial efficiency over technical perfection. It was heavier, simpler, tougher, easier to build, easier to maintain, easier to fly, easier to repair. It wasn't the best possible fighter. It was the fighter that could be produced by the millions and flown by pilots with minimal training. The Thunderbolt was test-flown multiple times at Rechlin over several weeks. Each flight revealed the same pattern. American engineering focused on production capacity, not aircraft performance. German engineers documented everything. Detailed reports described the structure, systems, performance characteristics, and combat implications. The reports reached senior Luftwaffe leadership. Some officers understood the implications. Others dismissed them. German aircraft were technically superior. German pilots were better trained. Quality would triumph over quantity. But combat results told a different story. After testing at Rechlin was complete, the captured Thunderbolt, now coded T9+FK in German markings, was transferred to a special Luftwaffe unit called Zirkus Rosarius. The official designation was Second Staffel, Versuchsverband Oberbefehlshaber der Luftwaffe. It was commanded by Hauptmann Theodor Rosarius. Zirkus Rosarius had one mission: demonstrate captured Allied aircraft to front-line Luftwaffe units. The unit toured German air bases across occupied Europe, showing German pilots what enemy aircraft looked like up close, explaining their characteristics, strengths, and weaknesses. German pilots could examine the aircraft, sit in cockpits, and watch demonstration flights. Rosarius flew the Thunderbolt to bases in Germany, Austria, and France through early 1944. German pilots crowded around the big American fighter, surprised by its size and weight. Rosarius explained what Rechlin had learned. The Thunderbolt was slow to turn below, 15,000 feet. Attack from below in a climbing turn to get inside its radius, but above 20,000 feet, don't turn with it. Use speed, diving attacks, hit-and-run tactics. Never assume battle damage will bring it down. Keep shooting until you see structural failure. Many German pilots looked skeptical. The Thunderbolt seemed so heavy, so awkward. How much threat could it really be? They were experienced. They'd been fighting for years. They knew air combat. What could this American machine teach them? Then German pilots started dying at increasing rates. In January 1944, American Thunderbolt production reached industrial scales Germany couldn't match. Republic Aviation's original plant in Farmingdale, Long Island, New York, covered over 1 million square feet of factory space, employing 23,000 workers in 3 shifts. The facility produced approximately 200 P-47s per month, 1 complete aircraft every 3.6 hours, around the clock. The Evansville, Indiana plant, opened in September 1943, added another 100 aircraft per month from over 1.2 million square feet of factory space, with 18,000 workers. Production would increase to 130 per month by summer. Curtiss-Wright Corporation in Buffalo, New York, manufactured P-47Gs under license, adding approximately 50 aircraft monthly. Combined output exceeded 350 Thunderbolts per month, over 11 aircraft per day arriving at ports for England. The production advantage extended to pilots. The United States Army Air Force's training pipeline produced over 2,000 newly qualified fighter pilots monthly from bases across America. New pilots received approximately 300 hours of flight training, including 50 hours in their combat aircraft type. They arrived in England and joined squadrons with experienced leaders who mentored them through first missions. If they survived initial combat, skills improved rapidly through careful instruction. German pilot training had collapsed. Fuel shortages, limited flying time. Aircraft shortages meant training on obsolete types. Instructor shortages meant inexperienced teachers. New German pilots arrived at combat units with less than 100 hours total time, sometimes as few as 10 hours in their assigned aircraft. They faced American pilots with 3 times the training and often months of combat experience. German pilot losses exceeded replacement rates. Veterans died. New pilots died on first missions. Squadron strength decreased despite new aircraft from factories. By January 1944, American Thunderbolt pilots had 9 months of combat experience. They'd learned what worked. They stopped trying to turn with German fighters at low altitude. Instead, they climbed to 30,000 feet before entering German airspace. When they spotted enemy aircraft below, they dove from above, building speed to over 650 kilometers per hour. They'd fire bursts from 8 guns, then zoom back to altitude before German fighters could respond. The 8 machine guns proved brutally effective. American pilots didn't need perfect aim. They pointed generally at the target and held the trigger. With 400 rounds per gun, they could afford to miss. The sheer volume of bullets created a killing zone 30 meters wide and 100 meters long. The .50 caliber Browning fired rounds weighing 43 grams at 890 meters per second. 8 guns firing together produced 34 kilograms of bullets per second. A 3-second burst put over 100 kilograms of metal into the target area. German pilots reported that Thunderbolt attacks felt like flying into walls of metal. Rounds didn't need to hit critical components. Multiple hits anywhere caused cumulative structural damage. Wing skins cracked from repeated impacts. Control surface. Hinges failed from stress. Engine cowlings shredded, affecting cooling. Fuel tanks leaked from near misses, rupturing seams. Cockpit impacts stunned pilots, even when armor stopped penetration. The psychological impact was severe. German pilots who dominated air combat for years suddenly felt vulnerable. The Thunderbolts attacked from above with overwhelming firepower. German pilots couldn't climb fast enough to meet them, couldn't turn tight enough to evade, couldn't damage them enough to bring them down. And there were always more of them. Shoot down 1 Thunderbolt and 2 more appeared. The endless American numbers wore down German morale as effectively as bullets wore down aircraft. Combat loss statistics told the story. In January 1944, 8th Air Force P-47 groups flew over 10,000 sorties. They claimed 114 enemy aircraft destroyed in air combat. They lost 38 Thunderbolts to all causes, including flak, mechanical failure, and combat. The kill ratio was 3-to-1 in favor of Americans, but more importantly, loss rates per sortie were microscopic. Less than 0.4% of sorties resulted in aircraft lost. German fighter units were losing 2 to 3% of aircraft per mission. The 56th Fighter Group, based at Boxted, England, illustrated American effectiveness. The 56th had been flying P-47s since April 1943. By January 1944, they had 9 months of experience. They knew their aircraft's capabilities intimately. They developed tactics that worked. In January alone, the 56th destroyed 78 German aircraft confirmed, plus dozens more unconfirmed. They lost 6 Thunderbolts total. The ratio was 13-to-1. Individual pilots racked up impressive scores. Captain Robert Johnson destroyed 5 German aircraft in January. Major Gerald Johnson destroyed 4. The group's success came from experience, tactics, and aircraft that let them survive mistakes while learning. Other Thunderbolt groups showed similar improvements. The 78th Fighter Group destroyed 62 German aircraft in January, losing 4 Thunderbolts. The 356th Fighter Group destroyed 48, losing 5. Across all P-47 units, the pattern was consistent. Kill ratios heavily favored Americans. Loss rates remained low. Replacement aircraft and pilots arrived faster than losses occurred. American strength grew while German strength declined. Major Gerhard Roth was one of the Luftwaffe's most successful night fighter pilots, with 58 confirmed aerial victories, all against RAF bombers at night. He flew Messerschmitt Bf 110 heavy fighters and Junkers Ju-88 night fighters. Raht was awarded the Knight's Cross with oak leaves and was the 10th most successful night fighter pilot in history. His expertise was flying instruments in darkness, using radar to intercept British bombers. In February 1944, Raht attended a Zircus Rosarius demonstration at his base, where Rosarius showed captured Allied aircraft, including the Thunderbolt. Raht examined the American fighter and was struck by how different it was from anything Luftwaffe flew. The overbuilt structure, the massive engine, the simple, rugged systems, everything designed for production and survival rather than performance and efficiency. Raht understood immediately what this represented. The Luftwaffe was fighting a different kind of war than they'd prepared for. German aircraft were masterpieces of engineering, each one carefully designed, precisely built, beautifully balanced, but they were fragile. When hit, they failed catastrophically, and there were never enough of them. American aircraft were crude by comparison, but they were tough. When hit, they absorbed damage and kept flying, and they came in endless numbers. Raht said to his fellow officers after the demonstration, "We can shoot down 10 of these, and 20 more arrive the next day." That's the real problem. Not the aircraft, the production system behind them. German pilot losses accelerated through winter and spring 1944. In February, Luftwaffe fighter strength on the Western Front dropped 12% despite new aircraft from factories. March saw losses of 15%. April losses reached 17%. The problem wasn't aircraft production. Germany was building over 900 fighters monthly. The problem was pilots. Experienced pilots died faster than training schools could replace them. A newly trained German pilot with 200 hours of training and no combat experience survived an average of 3 missions before being killed. The Luftwaffe shortened training to increase pilot throughput. That made it worse. Pilots with 100 hours of training died on their first mission. Americans had the opposite problem. They had too many trained pilots. The United States Army Air Forces produced over 2,000 newly qualified fighter pilots monthly from training schools across America. Most had 300 hours of training, including 50 hours in their combat aircraft. They arrived in England, joined operational units, and flew first missions with experienced leaders. American replacement pilots had time to learn. If they survived their first 5 missions, survival probability increased dramatically. The Thunderbolt's ruggedness meant mistakes didn't always equal death. A pilot could be hit, damaged, and still make it home to learn from experience. German pilots in lighter, more fragile aircraft died from the same mistakes. By March 1944, average Luftwaffe pilot experience on the Western Front dropped below 100 total flying hours. Average American Thunderbolt pilot experience exceeded 300 hours. The experience gap meant German pilots lost fights they should have won based on aircraft performance alone. And the Thunderbolts kept coming in numbers Germany couldn't match. Every day, more arrived at English ports. Every week, new pilots joined squadrons. Every month, American strength increased while German strength decreased. When Germans shot down a Thunderbolt, 2 more replaced it within days. When Germans killed an American pilot, 2 trained replacements arrived within a week. The American system operated like a machine producing aircraft, and pilots faster than Germans could destroy them. German commanders recognized the crisis and tried desperately to adapt. Luftwaffe Tactical Headquarters issued new directives throughout winter and spring, 1944. Orders emphasized avoiding high-altitude combat where Thunderbolts excelled. Pilots were instructed to attack only when holding altitude advantage. They were told to use hit-and-run tactics at low altitude where Thunderbolt performance was weakest. They were ordered to disengage immediately if American fighters gained advantageous positions. The tactics made sense on paper. In practice, they failed repeatedly. The fundamental problem was that Thunderbolts didn't fight alone. They operated in formations of 16 to 48 aircraft with excellent radio communication and coordinated tactics. American flight leaders positioned their formations deliberately, usually at high altitude with sun behind them. They controlled the engagement geometry. German pilots trying to follow their new tactical directives found themselves forced into disadvantageous positions repeatedly. If German fighters climbed to gain altitude over American formations, the Thunderbolts dove away, building speed Germans couldn't match, then climbed back to altitude farther away. If Germans tried attacking from below at low altitude, they had to climb through the altitude band where Thunderbolts were fastest and most maneuverable. If Germans tried refusing combat entirely, American fighters escorted bombers unopposed to bend German cities and factories. The Luftwaffe couldn't win by fighting and couldn't afford not to fight. Individual German pilots developed personal tactics that sometimes worked. Some became expert at identifying isolated American stragglers and attacking before the formation could respond. Some mastered the art of diving attacks from directly above where American pilots had poor visibility. Some learned to fake attacks from one direction, then reverse suddenly, catching Americans in vulnerable turning positions. These tactics occasionally succeeded, but they required exceptional skill, perfect execution, and luck. Most German pilots lacked the experience for such complex maneuvers, and even successful attacks often failed to bring down Thunderbolts due to their structural toughness. The Luftwaffe tried concentrating fighters for mass attacks that might overwhelm American formations through sheer numbers. In theory, if 50 German fighters attacked 30 Thunderbolts simultaneously, from multiple directions, some Germans would get through defensive fire and score kills. In practice, coordinating 50 fighters was extraordinarily difficult. Radio communication was poor. Formation leaders had limited control. Weather scattered formations. And when mass attacks did occur, American defensive fire from hundreds of 50-caliber machine guns created lethal zones that German fighters had to fly through. Even if several Thunderbolts were shot down, German losses usually exceeded American losses. The kill ratio favored Americans even in mass combats. German technical services tried finding weaknesses in captured Thunderbolt wreckage that tactical units could exploit. Engineers examined every crashed P-47 they recovered. They measured armor thickness and angles. They mapped vulnerable components. They identified areas where battle damage had caused failures. Reports went to frontline units detailing attack recommendations. Aim for the oil cooler under the Josie 25 engine. Target the control linkages in the tail section. Fire at the wing root where control cables ran. Hit the turbocharger ducting that wrapped around the fuselage. Some pilots followed these recommendations and achieved kills. But most attacks still failed to bring down Thunderbolts, even when hitting supposedly vulnerable areas. The overbuilt structure meant that damage to one system rarely caused catastrophic failure. Oil cooler hits. The radial engine kept running despite oil loss. Control linkages damaged. Redundant systems allowed continued control. Wing root hits. Massive wing spars absorbed damage without structural failure. Turbocharger damage. The Thunderbolt could fly without the turbocharger, just at reduced altitude performance. The captured Thunderbolt at Rechlin and later with Zirkus Rosarius provided German pilots and engineers extensive knowledge of the aircraft's characteristics, construction, and capabilities. That knowledge helped to some degree. German pilots, who'd examined the aircraft up close and understood its systems, were more effective in combat against it. But knowledge alone couldn't overcome the fundamental imbalance. Germans understood what they faced. They just couldn't produce enough fighters or train enough pilots to counter it. Quality knowledge couldn't defeat quantity production. By March 1944, the Luftwaffe was losing the air war over Germany itself. American bomber formations struck deep into German territory with heavy fighter escort. German fighters attacked and sometimes inflicted heavy bomber losses. But escort fighters destroyed German defenders faster than training schools could replace them. Every major air battle reduced German fighter strength. The Luftwaffe was bleeding to death while American strength grew. The captured Thunderbolt, transferred to Zirkus Rosarius, continued demonstration duties through mid-1944. Rosarius demonstrated it dozens of times at bases across Germany. He emphasized characteristics, warned about capabilities, showed German pilots' attack methods. But fewer pilots came to demonstrations, not because they weren't interested, because there were fewer pilots. Losses exceeded replacement rates. The Luftwaffe was bleeding experienced veterans. Records show the captured Thunderbolt was last seen at Leipzig-Brandis airfield in August 1944. After that, documentation disappears. The aircraft may have been destroyed in combat, damaged beyond repair, or abandoned as German forces retreated. American investigators searched for it after the war, but found no trace. It vanished into the chaos of Germany's collapse. Hans Werner Lörsch survived the war. He was captured by Allied forces in May 1945. American intelligence officers interrogated him extensively about captured aircraft evaluations. In 1946, Lörsch was recruited as part of Operation Paperclip, the American program bringing German scientists and engineers to the United States. Over 1,600 German technical personnel were relocated to America between 1945 and 1959. Lörsch was sent to Wright-Patterson Air Force Base in Ohio, where he worked until 1968, evaluating aircraft and training test pilots. He became an American citizen and spent his career studying aircraft performance. In the 1970s, he wrote a memoir titled Luftwaffe Test Pilot, Flying Captured Allied Aircraft of World War II. In his memoir, Lörsch devoted an entire chapter to the P-47. He wrote that flying the Thunderbolt was his introduction to American engineering philosophy. Americans didn't build aircraft to be perfect. They built them to be good enough, then built thousands of them. He'd initially thought it was crude engineering. Years later, he understood it was brilliant strategy. William Roach remained at Stalag Luft 1 until Soviet forces liberated the camp in late April 1945. He returned to the United States, left the military, and worked as a commercial pilot. He rarely discussed his capture. When asked, he'd say he made a navigation error that gave Germany their first complete Thunderbolt. But by the time they figured out what it meant, America had already built 10,000 more, so it didn't matter much. Theodor Rosarius, commander of Zirkus Rosarius, was captured by Soviet forces in April 1945. He spent 5 years in Soviet prison camps before release in 1950. He returned to West Germany and worked as an aviation consultant until retirement. He died in 1979. Before his death, Rosarius gave an interview to a West German television program about his wartime service, demonstrating captured aircraft. He was asked what lesson he learned. Rosarius said they showed German pilots Allied aircraft to help them understand enemy capabilities. But after the war, he realized they taught the wrong lesson. They showed pilots how to fight American fighters one-on-one. They should have shown them the factories. Because the real threat wasn't the aircraft. It was the production system that built them. You could shoot down 100 Thunderbolts, and it didn't matter because 150 more arrived that week. That's what Germany was fighting. Not pilots, not aircraft. The whole American industrial machine. And there was no tactical solution to that problem. The P-47 Thunderbolt became the most produced American fighter of World War II. Republic Aviation built 15,683 Thunderbolts between 1941 and 1945. Production came from 3 facilities, approximately 9,000 from Farmingdale, New York, 6,200 from Evansville, Indiana, and 354 P-47Gs from Curtiss-Wright in Buffalo, New York. That total exceeded combined production of all other American fighter types built during the same period except the North American P-51 Mustang. The production numbers were staggering by German standards. Germany's total fighter production for all types combined from all manufacturers peaked at approximately 1,500 aircraft per month in summer 1944. America was building more P-47s alone than Germany built fighters total. And America was simultaneously producing thousands of P-51 Mustangs, P-38 Lightnings, F-6F Hellcats for the Navy, and numerous other aircraft types. The industrial capacity gap was insurmountable. Thunderbolts equipped 51 fighter groups in the United States Army Air Forces, They served in every theater where American forces operated: Europe, Mediterranean, Pacific, China, Burma, India. They flew from England, Italy, France, New Guinea, Philippines, China, and island bases across the Pacific. The aircraft proved adaptable to every climate and every type of mission. Pilots flew them in sub-zero temperatures over Germany and in tropical heat over the Philippines. Mechanics maintained them in primitive jungle conditions and modern European airfields. The simple, rugged design functioned everywhere. Combat statistics validated the design philosophy. Thunderbolts flew over 546,000 combat sorties during the war. In air-to-air combat, they destroyed more than 11,000 enemy aircraft. Ground strafing attacks accounted for another 9,000 enemy aircraft destroyed. Ground attack missions also destroyed thousands of locomotives, trucks, tanks, and rail cars. The overall kill-to-loss ratio was 4.6 to 1, meaning nearly 5 enemy aircraft destroyed for every Thunderbolt lost. Loss rates averaged 0.07% per mission, less than 1 aircraft lost per 1,000 sorties flown. Those statistics represented more than numbers. Each sortie was a pilot's life at risk. Each kill prevented enemy attacks on American forces. Each ground target destroyed reduced enemy combat capability. The Thunderbolt's battlefield impact was enormous. In the European theater, Thunderbolt ground attacks systematically destroyed German transportation infrastructure. Locomotives couldn't move, trucks couldn't supply frontline units, tanks couldn't advance without fuel. The Thunderbolt's effectiveness as a fighter bomber was arguably more valuable than its role as an air superiority fighter. Pilot testimony overwhelmingly praised the aircraft's survivability. Robert Johnson, who scored 27 aerial victories flying Thunderbolts with the 56th Fighter Group, survived an engagement where German fighters hit his aircraft over 200 times with cannon and machine gun fire. His engine was damaged, his controls were shot, his fuselage was riddled with holes. But the Thunderbolt kept flying and brought him home. Johnson said after the war that no other fighter would have survived that level of damage. The Thunderbolt's toughness saved his life. Francis Gabreski, who scored 28 aerial victories in Thunderbolts to become the top-scoring American ace in Europe, said the aircraft's roomy cockpit and comfortable controls let pilots fly long missions without excessive fatigue. German fighters were cramped. Pilots developed cramps and circulation problems on missions longer than 2 hours. The Thunderbolt's spacious cockpit let pilots fly 4-hour missions comfortably. That endurance advantage allowed Americans to escort bombers to distant targets and maintain combat effectiveness throughout long flights. Hub Zemke, who commanded the 56th Fighter Group through most of its combat operations, emphasized the Thunderbolt's maintainability. He said crew chiefs could perform major repairs at forward airfields with basic tools and minimal parts. Aircraft damaged in morning missions could be repaired and flying again by evening. German fighters required specialized tools, trained technicians, and parts from central depots. Repair times were much longer. The Thunderbolt's maintenance advantage multiplied American numerical superiority because damaged aircraft returned to service faster. The Thunderbolt's success wasn't about being the best fighter. The P-51 Mustang was faster with longer range. The P-38 Lightning was more versatile. The Spitfire was more agile. But the Thunderbolt could be built faster, flown by less experienced pilots, maintained by mechanics with basic training, and repaired with simple tools. It matched America's strengths, industrial capacity, resources, and the ability to train large numbers of adequate pilots quickly. German aircraft designers continued building technically superior fighters until war's end. The Messerschmitt Me 262 jet was the fastest operational aircraft of the war. The Focke-Wulf Tar 152 was probably the finest piston-engine fighter ever designed. The Dornier Do 335 was an advanced jet bomber faster than any Allied fighter. All were engineering masterpieces. All were produced in numbers too small to matter. Germany built approximately 16,000 fighters in 1944, the peak production year. The United States built 96,000 that same year. The numbers weren't close. Germany couldn't win a war of production. But German leadership never fully accepted that reality until too late. The captured Thunderbolt that German engineers examined in late 1943 was one aircraft, but it represented a fleet of 15,000. Behind that fleet stood factories, workers, resources, transportation networks, training schools, and the industrial capacity of a nation built for mass production. Germany's engineers understood individual machines brilliantly. America understood industrial systems. That difference decided the war. Wars are won through logistics, production capacity, and ability to replace losses faster than enemies can inflict them. The Thunderbolt wasn't the best fighter of World War II, but it was the fighter that could be built in sufficient numbers to overwhelm technically superior opponents. Sometimes adequate but abundant beats, excellent but rare. If you found this story as compelling as we did, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters, each one deserves to be remembered, and we'd love to hear from you. Leave a comment below telling us where you're watching from. Our community spans from Texas to Tasmania. From veterans to history enthusiasts, you're part of something special here. Thank you for watching, and thank you for keeping these stories alive.